Okay, so ions. Ions are charged atoms, so they will have a different number of electrons than they do protons. They've either gained an electron and become more negatively charged, or they've lost an electron and become more positively charged. Metals on your periodic table, everything that was to the left of your periodic table, underneath that staircase, so your alkali metals, alkaline earth metals, transition metals, all these guys, okay? Everything on the left side of your periodic table, those are called cations. So cations, think of cats make you more positive, okay? So cats make you happy, cations. So cat positive ions. Ion means charged atom. So you have a positively charged atom. Metals often will lose their electrons. They're givers. So they're going to give up their electrons, typically to nonmetals. They're going to have an exchange. And when metals give up their electrons, that negatively charged subatomic particle, they themselves are going to become more positive, like cats. Nonmetals are called anions. So I think we've talked about anas. Okay, so ana, negative. If you know an ana, she's negative. And so most often in science, if you have an a or an in front of a root word, that will make it negative. Okay, so anions are negatively charged particles or atoms. So an, negative, and then ions. Ions are charged atoms, so negatively charged atoms. These are going to be your nonmetals. So your nonmetals, everything on the right-hand side of your periodic table, the elements that are typically gases at room temperature, all these guys, okay, like like nitrogen, oxygen, all your noble gases don't really count in this case, but oxygen, sodium, fluorine, chlorine, those are all nonmetals, and they're all anions. So they're takers. Okay, Anna is very selfish, and she'll take electrons. And so nonmetals are going to be taking electrons, and overall, they're going to become more negatively charged. Okay. If we look at polyatomic ions, we talked about polyatomic molecules. Polyatomic ions, you're going to see a lot more of them in grade 10. This group, or this kind of list that I have here on the slide, these are all the known, or not all actually, but a majority of the polyatomic ions that we know of. So again, poly means many. So polyatomic ions are molecules, compounds, and these compounds, these molecules of more than one of many atoms together, they actually have an overall charge, which is unique. So typically when we look at ions, we're looking at single elements, atoms, gaining or losing electrons. But polyatomic ions are unique. They're special because they're actually already groups of atoms together. They're molecules, and they overall can react with other elements and gain or lose electrons. So they're kind of like a special, unique group that have a charge. And so we have special names for these groups. Hydroxide, okay, is a common polyatomic ion. So it's oxygen, which is one atom, and hydrogen together. So it's poly, more than one atom, okay? And these two together, when you have oxygen and hydrogen together, they actually will overall hold a charge of -1. So these two gases, these two nonmetals, will often actually gain an additional electron when they react with something else to become more negatively charged. This list of polyatomic ions will always be given to you. You don't have to memorize this list or these names, but you do have to understand that if you ever see more than one atom together and they have a charge, that we call those polyatomic ions. So sulfate, for example, okay, if I showed you this, you should know that this is a polyatomic ion because it's not just one element, but it's more than one, it's two. You have one sulfur atom, there's an invisible one here after the S, and there are 4 oxygen atoms. So you have one sulfur plus 4 oxygen atoms. It's a compound, and this compound actually really wants to gain 2 electrons. It wants to react with another element or another compound to gain electrons, okay? And it's also 2 nonmetals, sulfur and oxygen. So nonmetals, like we just mentioned, are often trying to gain electrons. Okay, so they're greedy. Okay, I'm going to post this video, How Do Ions Form, on Google Classroom, and I would like you guys to watch this video. Ions, okay, how they're forming, there is an exchange of electrons. So like I had shown with lithium, okay, lithium will often give up its electron, but it is doing that and it's reacting with another element. So I'm going to show you an example of sodium and chlorine, table salt, okay? Sodium and chlorine is what we call an ionic compound. So sodium, Na, okay, is a metal. So it's on your left-hand side of the periodic table. Sodium, a metal, when it reacts with chlorine, a nonmetal, okay, it'll form table salt, sodium chloride. Okay? So what happens here, and there's an image here, sodium will have an extra electron on its outer ring that it wants to give up. And chlorine will actually have 7 electrons on its outer valence. So it is only 1 off from being full, from having 8. So it's in chlorine's best interest to take the electron from sodium so that it has a full ring of 8 electrons. Okay? And so what happens here with ionic compounds is there is an exchange. A metal will always give an electron and a non-metal will always gain an electron, or more than one. And so they actually exchange electrons. Okay? What you need to remember, and what will be reiterated in grade 10, is that ionic compounds are metals plus nonmetals. That is what characterizes an ionic compound. There is an exchange of electrons. Okay? Ionic compounds are good conductors of electricity. They're solid at room temperature, and that is because there is a metal, which is a good conductor of electricity and is typically solid at room temperature, and it's reacting with a nonmetal. If we then look at molecular compounds, what you need to remember is that they're actually 2 nonmetals reacting with each other. And with these 2 nonmetals are often very greedy. They want to gain electrons, right? They need electrons from metals in order to have full rings of electrons. So if you have 2 nonmetals interacting with each other, because they're greedy, they're not often going to just give up an electron or have some type of agreement where they lose one. So what 2 nonmetals will do is they'll actually share electrons. So they'll come to an agreement and they'll share so that they're both full. And we call that sharing of electrons a covalent bond. It's also called a molecular bond. So molecular compounds have molecular bonds. So neither element gives up or simply gains an electron. At best, they will share. And so if I drew water for you and how water looks as a molecule, you'll see that they're sharing electrons. So oxygen, okay, oxygen it's the eighth element on the periodic table, so it would have 8 protons in the nucleus, and it would have 8 neutrons. And it would then have 8 electrons. 2 in its first valence. Okay, so 2 electrons in its first valence here. And I just drew 8 for 8 protons and 8 for 8 neutrons. And then it's going to have 6 electrons in the second ring, right? 6 plus 2 would be 8, I hope. Okay. So here's 6, 2, 4, 6. So in order for oxygen to be full, it is actually missing 2 electrons. So it needs to find 2 electrons in order to be full, in order to be happy. Now hydrogen, okay, hydrogen is the first element on the periodic table, so it's going to have 1 proton and 1 neutron. And if you draw its first ring, it's going to have 1 electron. Okay, so 1 proton, 1 neutron, and then 1 electron in that outer ring. So in order for hydrogen to be full, it actually needs another electron there. Okay, and okay. So what's going to happen is hydrogen is actually going to attach to oxygen, and we're going to have 2 hydrogens attaching to oxygen. And this way, the oxygen atom and the hydrogen atom will both be full. Okay? They'll both have a full set of electrons. And what they're going to do is not exchange, but share, attach. Okay? So ionic compounds are metals and nonmetals, and they exchange electrons. Molecular compounds are 2 nonmetals, and they're going to share electrons. Okay, so here's another image that I was trying to show you with oxygen. Okay, and so here we're sharing electrons. Okay, I'm going to get you guys to possibly play a game of Kahoot. And so these links are going to be live. You guys can just add yourselves to the game. It's good practice. And that's it for this week. Okay? Have a good one.